Use the Pythagorean theorem to see if a triangle with sides of 6, 8, and 10 would make a right triangle. So let's start by writing down the Pythagorean theorem. A squared plus b squared equals c squared. We know the longest has to be your c, so let's go ahead and put that in, and then the other two are the legs. So 6 squared plus 8 squared. So 6 times 6 is 36 plus 64 equals 100, and we're testing this to see if the two sides do match. And yes, they do match, so yes, this would make it right triangle. Now I'll show you a little trick. We know that 3, 4, 5 is the most basic right triangle, and we can see that this would have been a similar triangle with all of the sides doubled. So we could have probably guessed without doing any work that yes, this was a right triangle, but it's always good to go through the process as well and double check yourself. You can use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. So if we're going from point to point, let's first draw our right triangle, and it'll be right here. So this tells us that the distance between the points is the hypotenuse, C. Here are our legs, A and B, and we need to count the distance. So this one, obviously A is 2, the distance from here to here, and the B is going to be 1, 2, 3, 4, 5, 6, 7, 8. So we're going to use our Pythagorean theorem to figure it out. A squared plus B squared equals C squared. That's the Pythagorean theorem. We know we're looking for the hypotenuse, C squared. So we have 2 squared plus 8 squared equals C squared. So 4 plus 64 equals C squared. 68 equals C squared. Now there's no integer that comes out evenly for C here, because the square root of C squared is C, but the square root of 68, well, that's going to be a little bit more than 8, so you're going to probably need to use a calculator for that, and you're going to find out it's about, so we'll use the squiggly equal, 8.2. So we would say C is about 8.2 units.